Raymarcher is a part of Unity's default rendering pipeline. However, Raymarcher expands the pipeline with additional steps necessary to properly process the final frame and deliver it to the screen. The Raymarcher rendering pipeline is categorized into 3 major stages: data retrieval stage, shader stage, and final delivery stage. Each stage has a specific task for handling certain data and dispatching it to the GPU, resulting in the content displayed on the screen. You can find a detailed description of each stage in the official technical documentation. In the Unity engine, after setting up the Raymarcher renderer, each Raymarcher session is stored in the Raymarcher renderer game object, which contains a component called RenderMaster. The RenderMaster is the core monoclass of the Raymarcher renderer, containing various subclasses, each dedicated to handling specific tasks. In the Unity inspector, you can control all the settings and features that the Raymarcher offers. At the very top, you can find the Session Information panel and a Convertor panel, both allowing you to manipulate the Raymarcher session. There are 2 ways to remove the Raymarcher session. You can directly remove the game object of the renderer, or you can click the button on the RenderMaster component to remove the current Raymarcher session. This action will completely remove the current Raymarcher session, along with its all dependencies and shaders, and there is no way to undo it, so consider this action carefully. It's also possible to clone or duplicate the Raymarcher session. You can do this by clicking the Clone Raymarcher Session button on the RenderMaster component. This is especially helpful when you want to have the current Raymarcher session settings in a different Unity scene. It's not recommended to use the same Raymarcher session in multiple Unity scenes, as shader conflicts may occur. Enter a new unique session name and click Clone. A brand new Raymarcher session will be created, and you are entirely responsible for the old one. The converter is a crucial component in the Raymarcher. It converts human interactions to the shader language at compile time. Every new SDF object creation, material change, or render feature change requires a shader recompilation, which is possible only at compile time. This means that creating new SDF objects or changing materials of the SDF objects at runtime is not possible. However, you can write a custom pool to manage that. You can enable a field that will auto-recompile all the compiler requests automatically. If you make any changes in the Raymarcher and can't see the results, you can manually invoke the Raymarcher converter to send a message to the compiler regarding the need to compile anything. There are 2 major buffers in the Raymarcher: the object buffer and the material buffer. The object buffer handles all the registered Raymarcher objects, SDF formulas and modifiers. The material buffer handles all the registered material instances in the Raymarcher. An extra button for the Raymarcher session handles the actual master shader of the session. There is a shortcut in the scene view to manually invoke the converter to compile either the object buffer or the material buffer. The Raymarcher will warn you if the recompilation is needed. However, as mentioned earlier, you can enable the auto-recompile option, so the Raymarcher will handle this automatically. If you don't see the results you have made, you can manually recompile all the buffers via the shortcut in the scene view. If you don't like the shortcut, you can disable it in the RenderMaster. RenderMaster presets enable you to create presets of the current renderer settings. That means that you can save the current render data, material global features and settings, and lighting data as scriptable objects as the preset. This feature is still in an experimental version, or it might be, depending on when you are watching this video, as it might have some flaws requiring further testing and development. You can utilize the created presets to reuse the render settings in another Raymarcher session without the need for manual field-by-field copying. In the first scene, I have a material session with its own unique settings, and in the second scene, I have a completely different settings. If I wish to synchronize the settings from one session to another, I can create a preset in the first scene's render and load that preset in the second scene. This allows me to maintain all global material settings, rendering data and lighting data in the same place. In the Render Settings section, you can control the render target platform, render type, iterations, maximum distance, and render precision. The higher the value of the render iterations, the more performance it consumes, as each draw call iterates the specific number of times. If you want to change the target platform or render type, the Raymarcher will prompt you to recompile the session. In the Render Features section, you can control the global visuals of the Raymarcher renderer. I can experiment with the Raymarcher renderer features, resulting in various interesting results. I'm going to create a simple primitives in the scene mixed with regular unit meshes. I will get back to the Raymarcher objects and materials shortly in this video. In the Render Lighting section, you can define the main directional light and additional lights. Each light component has a damping slider that allows you to dampen the intensity of the light, as HDRP and URP use different light setting scales. To use additional lights, you can add or remove a light element. However, keep in mind that once you make a change to the additional lights collection, it is necessary to recompile the light database. Please note that the lighting significantly depends on the material used on the Raymarcher objects in your scene. Currently, I am using a lit material on my objects, which supports both the main and additional lights. Lighting is also closely related to the material settings that each Raymarcher object has. I will cover that aspect later in the Raymarcher materials documentation. Last but not least, there is a significant section called Render Materials. Raymarcher has its own material pipeline that works and handles data in a specific way. The materials in the Raymarcher are divided into global materials and per instance materials. I will delve into the materials in the Raymarcher in another video. In this section, you can preview the currently used material types and material instances. Currently, I am using just one material type. If I change a material type on one of my objects, for example, by adding a PBR material, I can see that it is displayed in the preview list. You can also utilize global materials that are applied globally and equally to all Raymarcher objects. However, I will cover this in a dedicated video about Raymarcher materials. At the bottom of the section, each material type contains global material features and settings. Currently, I'm using two material types that share common global material features and settings. Since they belong to the same material family, there is only one large panel that controls the global material features and settings for both material types. Here I can enable or disable various features of that material family, including lighting, shadows, Fresnel effects, and so on. Hence the performance cost progress bar. The more features I enable, the more performance it consumes, so think twice while working with material features. Also, the higher the render type and the more features you use, the more time it takes to finish the shader compilation. Alright, that was a detailed description of the render master. Now let's create some Raymarcher objects. Raymarcher features a diverse collection of primitive objects, fractals and volumes. In this part, I'm going to demonstrate how to create the Raymarcher objects, apply a material to it and work with it. You can create a Raymarcher object by the hierarchy create button Raymarcher, and you can select your desired category. I'm going to create a primitive metaball object. Each Raymarcher object has its own unique parameters. I have currently selected a quality render type, which allows me to set the color of the object, including a custom material instance or a texture. You can also blend all the objects with another. To work with textures in the Raymarcher, ensure your textures have the same dimensions and are read-write enabled. The same applies to the material instances and their texture inputs. In the current version of the Raymarcher, if I change the render type to performant or standard, I'm not able to use the full color spectrum on SDF objects. Instead, I can use a hue shift. I can also globally offset the hue shift on all objects equally and change their saturation. This might change in the future. Now let's create a material for our objects. Go to the project window, right-click and search for Raymarcher. I'm going to create a PBR material for a simple demonstration. Every Raymarcher object material instance inherits from a scriptable object. Assign the material to the game objects in the scene. As mentioned earlier, each material type has its own global material features and settings. If I select the material renderer, you can see that we have even more features, and you can also see our material type in the preview list. I will talk about the materials in its dedicated documentation video. I can now apply a modifier to my object that will modify the current sign distance function. There are plenty of modifiers available and I will talk about them in a separate video. It is possible to create the prefab of the Raymarcher objects, but only at compile time, meaning only in the editor before the application has been built. Please note that the more Raymarcher objects you create, the more allocations and memory it consumes. Alright, that was everything about the Raymarcher essentials. Thanks for watching and good luck.